Okay, so we were talking about users and users, and we're going to continue talking about issues in software engineering that have to do with dealing with our end users. The first issue is use case models. The second issue is user interface design. Okay, so use cases then are models of an aspect of the system. Just like architects draw different kinds of architectural diagrams, they will draw plumbing diagrams, electrical diagrams, and so on. These diagrams are kind of like diagrams that show where you walk through the building, okay, if you're an architect. All right? So it's a typical sequence of actions that a user performs as they're doing a particular task. So you're going to have many, many use cases, one for each particular task that users will do. Okay? And use case analysis is the process of doing this generation of a set of use cases. Okay? And what we're going to do is we're going to do it from the point of view of how users interact while they're trying to achieve a particular objective. Okay? So if a user's objective, if a student is trying to register in a course, the objective is to register in a particular course, the use case will go from the time they start to get into the system through until the system gives them feedback to say, yes, you've registered in this course, and they get out. Okay? So it'll take them through the steps, the sequence, all the way through. The model is the set of use cases, the entire set, and you may also create a diagram showing how use cases are related. And we'll see that in a second. Okay, a few general things about each individual use case. We looked at use cases briefly in Chapter 4, but now we're going to be getting into a lot more detail about them. Okay? It should cover the full sequence of steps. So, user does something, system responds. User does something, system responds. All the way through until the user clicks OK and the system says you're done. Okay? All the way through. Sequence of steps. 1, 1, 1, 1. They aren't like algorithms in the sense that they don't have if, then, else, and loops and things like that. If you have more than one way of doing things or more than one way of path through the system, you have multiple use cases. Very important point. Okay? It's describing the user's interaction. Use cases are not describing, as I said, algorithms. They're not describing the system's computation. That's a totally different kind of a software engineering model. Very important algorithms are, but then that's not what use cases do. Use cases are dealing with the human being's interaction. Or possibly some automated thing, like a robot or some other computer system that says, I want to do this with you, here's the response. I want to do this with you, here's the response. So we can consider that we can extend the concept of user to the broader concept of actor, which is anything using a system. But it has to be something external using a system. Okay? We want to make the use case independent as much as possible, although it's not always completely possible, but as much as possible, of the user interface design. Okay, so you're going to say the user selects an item and the system displays information about that item. You're not going to describe in the use case whether it's selected in a list or a set of checkboxes or a set of some pull-down menu or something like that. That kind of issue is left until user interface design. So use cases try to be independent of the UI from that respect. Okay? And finally, a use case should only include those actions in which the user actually interacts with the computer. So, for example, if I go into a library and I browse through the shelves, I find a book, I take it down to the automated book checkout thing, and I stick it in the machine, and then the machine tells me you're checked out and I go. The use case is stick a book in the machine, the thing says beep, you've got until this date, and I leave. Okay? The process of manually going through the bookshelves finding a book is just, the user does it, but it's nothing to do with the use case. Use case is strictly interaction with the computer. Okay? So these rules are important. A lot of people, when they're doing use cases, they break some of these rules, and they're not then doing proper use case analysis. Okay? Any questions about this? Okay. Another concept that we have to know, a piece of terminology, a scenario. Okay? A scenario is an instance of a use case. So a use case is generic, like a class is generic. And a scenario is specific in that you're talking about specific data. You instantiate the data, you instantiate the people or whatever. You don't say, in general, a person stuck a book into the system and checked it out, you say, book with such and such a code was put into the system, and the system displayed exactly the following message that your book is due, or the book Gulliver's Travels is due October the 30th, 2003. Okay, so that's a scenario which is more specific. There's more details of the instances and the actual data involved in a scenario. So there can be many scenarios for a use case, and you just have to think of them as instances. You will find in various pieces of literature some different terminology surrounding use cases and scenarios. This is the terminology that I adopt that is consistent with UML. Some books just use the term scenario when they mean use case. Others use various other pieces of terminology, which you might hear from time to time, but we'll just concern ourselves with use cases and scenarios. There's a piece of terminology called task analysis, so sometimes people just talk about these things as tasks. Okay, that's another one that sometimes you hear. We've talked in the past about ways of documenting, ways of describing things. So I gave you a set of headings that would be a good set of headings to use if you're describing, for example, a requirements document, or if you're describing a domain analysis document. Okay? This is a set of headings for describing a use case. This is a standardized, good set of suggestions. If you're creating a use case, give it a name, first of all. A name that's descriptive, that basically summarizes what the user is doing in this particular use case. Secondly, who does it? What kinds of users do it? What are the actors? Okay, sometimes one kind of actor, the people on the front lines, the hotel clerks do it. Another kind of use case is done by managers. Right? So different use cases done by different actors, we want to know. Some use cases are done by all actors, and we want to know that too. Okay? Thirdly, what are the goals of the actor? What is the actor trying to achieve? What is the end result the actor is trying to achieve? All of these things can be very, very short. They don't have to be lengthy. Just a couple of words will do sometimes in these cases. Preconditions. What is true about the system or about the actor before we start? Okay, we have to, for example, assume in some use cases that the user, the actor, has found certain information that they can work with. Okay, in other use cases, the system has to have loaded certain information or be on a certain screen. Okay, so what is the starting point? The description is an informal description. Sometimes you can leave some of these things out. The related use cases, and there's another thing, what are other use cases that they're doing similar things but with slightly different results or slightly different things happening? The most important one, other than name, is the steps. Okay, so we can, if we want to be quick and brief about it, we can just put name and steps. So the steps are, again, what does the user do? How does the system respond? What does the user do? How does the system respond? Going down till the end, the use case finishes. The user achieves their goal. Or doesn't achieve their goal. It's possible for a use case to be a situation where the user fails to achieve their goal, and the final response is the system displaying some kind of error message. Okay, that would also be a use case. And in fact, you very often have more of those failure cases because there are more ways things can go wrong than things can go right. Okay, everything has to be in place for things to go right, but you can have a use case that describes everything that can go wrong, one for each thing that can go wrong. Okay? Post-conditions are things that are then true. So, for example, you might say, well, after this use case is finished, the database has this information in it, the following things would happen, the next time this is done, the following message would occur. Anything that you want to say that will be true in subsequent interaction with the system that wouldn't have been true at the start. Okay? We're going to see some examples of these. First of all, a use case diagram. This is a formal part of the use case, the UML set of diagrams. It's part of the UML repertoire. It's one of the diagram styles. It's got two main symbols on it. The actor, represented by a stick person, and the use case represented by an ellipse with the name of the use case in it. Okay, so in this case we're saying that the registrar actor, we don't actually have to use the word actor every time, but I'm emphasizing that here. The registrar can add course offerings, add courses, and find information about a course. The student can register in a course or find information about it, and the professor can enter a grade and find information about a course. Okay, so different things doable by different types of actors. Presumably there's some kind of login, and the system knows what kinds of logins correspond to what kind of permissions to do these various things. Okay? Any questions so far? I consider use case diagrams to be the least useful. The least useful of the UML diagrams. The reason why they're least useful is because there's less information here. You can easily list this in text in about 20 lines, and people can easily see. Whereas you couldn't list a class diagram or a state diagram or some of the other diagrams textually and have the same rich ability to understand what's going on. Okay? So use case diagrams can be useful for presenting information to end users, or for allowing people to quickly glance and sort of have a visual representation. But they're not strictly necessary. You can get away with just listing use cases textually. Okay? There's a few things that we can do in use case diagrams to add interesting add-ons. The first of these is called an extension. Okay? Extensions show optional interactions to handle exceptional cases. So I talked about things going wrong. You often have more use cases that show the things going wrong. Okay? Well, these can be represented as extensions, okay, that show particular paths the user does when things go wrong. And the idea is that by showing it these extension use cases separately, you're not confusing the main path. The main path is shown as, here's the normal way when everything goes right. You know, the student logs in, the student finds, brings up the display of what the courses available to them. They click on the course they want, they click register, the system says okay, and they're done. That's the normal path, everything working fine. There's plenty of exception paths in there. You know, the course they want is not available to them. The course they want is full. The course they want, they don't have a prerequisite for it. Okay, all kinds of exceptional cases. We could represent them as extensions. Okay, sometimes use case modeling, you don't do all the extensions, you just focus on the main paths, and you just list extensions informally. But if you want to do a full-fledged model, you should show all the extensions separately, as here are other things that can go wrong, and here's how the system is going to respond whenever these things go wrong. Okay? One of the important things to remember, and the last point on this slide, is that in an extension, if you're doing it properly, if you're following the standard methodology, you're going to list all the steps from beginning to end in the exceptional case. So the user comes in, the user logs on, the user displays the screen that shows the courses that are available to them, or their current thing. The user clicks on a course, and the user is told that that course is now full. Okay, and that is the end. Okay, so it's basically the same thing up until that point. That's the standard way of doing this. Personally, I don't like the duplication. I'm not sure I'm particularly fond of that approach to show that, but that is the standard approach to do things. I would be inclined to accept use case models that just sort of showed snippets of where things go wrong and without repeating everything from the beginning. We're going to see a couple of these in a minute. Generalizations, okay, are just like superclasses in class diagrams. They're showing general cases, grouping several use cases together that have some similar features. We'll see a few examples of those in a minute. I think the concept of generalization should be pretty clear. Same symbol is used. The triangle pointing to the most general case. Inclusions are used to show common repeated sequences. So for example, if login was something that is done over and over again and it's a several-step process, I can write a use case for login. And then later on, when I'm showing other use cases, I can just say login without having to repeat those sequences over and over again. So this is one of the ways of getting rid of the duplication and making sure that we reuse stuff. So it's reuse of use cases effectively. Inclusions. Okay, so I think that's relatively clear. Generally speaking, the inclusions represent the performing a lower level task. Okay, so logging in is a lower level task with a lower level goal of getting into the system, whereas the registering is a higher level task with a higher level goal. Okay. Slide 13 shows a use case diagram where we're showing a few more of these features. So, first of all, we're showing ordinary users can do open file. Open file, however, is general. It is a generalization of several specialized open file use cases. One of them is open file by typing name. Another one is open file by browsing. So different ways of opening files, different modes with which the user can achieve the same goal, where they'll do different sequences of actions. Okay, but ultimately, there is an open file. In the book, you'll see the details of all of these use cases. Okay. There is an extension of open file by typing name that shows the exceptional case where attempting to open a file that doesn't exist. Okay, so you type a name that's garbage, that doesn't exist, and the system is going to give you a message saying that doesn't exist. In the normal case, the file actually will open. Okay, but in the exceptional case, it will display an error message. And so this is an extension to show what happens under those circumstances. And finally, we have browsing for file as an inclusion in open file by browsing. Because browsing for file can be done in many circumstances. Not just when opening a file, but when you want to save a file. You browse for the location that you want to overwrite a file. Okay, so browsing can be done in many different circumstances. And so we create a browsing inclusion, a special use case to do browsing. And then when we're describing open file by browsing, we just say, as one step, browse for file. And that's all we say. The details of how you browse and the clicking that you have to go through can be left to a much more detailed, included use case. Okay, so notice the kinds of symbology here. The triangle pointing upwards to the open file, that's the generalization. Same symbol as class diagram. This same symbol is used throughout UML, meaning here's the general case. Okay, you can do that in other diagrams too. The arrow is an association, except in this case we're talking about associations in the context of use cases. One use case is associated with another. We're using particular stereotypes using these double angle brackets. Okay, so extend is a built-in stereotype in UML, includes is another one. And we also have generalization of the actors themselves. Okay, we're saying the system administrator is a special kind of ordinary user. This is all users, okay? And system administrator is one special kind of that. Okay, so again, the same generalization symbol. Questions?
So, for the generalizations for the people, the actors, it's not a normal is a rule.
It basically is the normal is a rule. So what we're saying is the system administrator is just an ordinary user, but they have special privileges. So you're basically extending the privileges or adding additional privileges, but that they can do everything that this can do. So the ordinary user can do things. The system administrator can do all of those things, plus a few other things. So yeah, the is a rule should still apply. Opening file by typing name is a case of opening file. Okay, so here is a description of a particular use case. Open file. I'm not giving all of those headings that I said, preconditions, postconditions, etc. I'm just leaving some of them out to simplify things. As I said, the important one is you have the name and you have the steps. So the name is open file. It's got some related use cases. So open file by typing name, okay, is a sub-use case, a special case. So this is a generalization of open file by typing name and open file by browsing. Then we have the steps. Okay, I've columnized them. I said actor action, system responses. I like this style. Not every book uses this style. Some books just list them in one column. Here are the steps, step 1, 2, 3, 4, 5. I like to put them in 2 columns. Here's what the actor does. Here's what the system does. Okay? I find that that makes things clearer. So the actor chooses an open command of some kind. It doesn't say how, so it's not user interface specific. It's not saying if it's done by pulling down from the menu or by clicking on some icon somewhere. It just says the user chooses an open command. Some kind of file open dialog appears. We're not describing what it looks like. The user specifies a file name, okay, and confirms the selection that they want. We're not saying how it's confirmed, whether it's confirmed merely by hitting enter or whether it's confirmed by clicking on an OK button. That's up to the user interface design to determine. And then the dialog disappears. Okay? A post-condition of this would be, in general, that the file actually opens. The file is then opened. We could put that in as a system. Dialog disappears, system as file opens. Okay? So that could be put in. There's some flexibility here in what the endpoint is. Any questions about this? Okay? Open file by typing name. We said this is going to be a specialization. Okay? So it's a specialization of the open file that was on the previous slide. First actor action, choose open command, file open dialog appears. Same thing. 3A, 3B. I've used the same numbering scheme from the previous one so that we can match them up. Step 3 on a previous slide said specify file name. Here it's select text field, type file name. Okay, so we're specializing the details of type file, of specify file name into selecting and typing. Clicking open is specializing the confirm approach. Okay, how do we confirm the selection? And then the dialog disappears is the same thing. Okay, so a lot of it is the same, but we've added some extra details and we're specifying in a bit more, in more specificity. So that's why it's a specialization. Okay? But these are trivial use cases, by the way. In a real complicated system, you might be many, 20, 30 steps and much more sophistication. So I'm just illustrating the concept using simple cases so that you understand it. One question might be coming to you is, why do this? What's the point? The point is to make sure that we have carefully thought about how the user is going to interact with the system and make sure that we've covered all of the details of what users are likely to want to do, different ways of doing things. How is the system going to give good feedback, good response, good messages under the right circumstances? Is this a sequence that will be easy to do for users? Okay, sometimes you come up with complicated sequences that require going backwards and forwards to all kinds of places. You'd like the fewest steps possible to do a task. And the user have to be easy. The user presses buttons and clicks the mouse all in the same place, okay? So, whereas there's not much scope for simplifying these cases, if you have a 20, 30 step use case, you might be able to shuffle the order around and cut out some steps, automate some steps. And so the analysis process would involve that simplification. Okay. Open file by browsing is another specialization of open file. So again, we have choose open command, file open dialog appears. Same thing. This time, browse for file. But you'll notice that is just an inclusion use case. Okay, so somewhere else is a use case that says how do you browse for file. And then confirm selection, we're not saying how, whether it's done by clicking OK or hitting return. Maybe both of them work. We're leaving that aside. That's user interface design, perhaps. Dialog disappears. So a lot of it's the same. The main difference is browse for file. And an exception use case, attempt to open a file that does not exist. Okay? So we're choosing the open command, file open dialog appears, the same thing. Then the user selects text field, types file name, clicks open, and the system indicates the file does not exist. So that's the main difference here. The user corrects the file name. Now we're going on to a slightly different path through the system. How does the user recover from the error is one of the important things that you might well put in one of these use cases describing an exception. Okay? The user corrects the file name, clicks open, and the dialog disappears. Okay? This could go on forever. Step 6 could be repeated. You can sometimes say, repeat step 6 as many times as necessary. Okay, there's quite a bit of flexibility here. Some purists would say you shouldn't put things like repeat, but sometimes it's practical and useful to do that. But you don't have big loops and nested loops and if-then-else's too much in use cases. It's considered really they're not use cases if you do that. Okay. And here is the inclusion use case, browse for file. Okay, so first of all, if the desired file is not displayed, select a directory, select a folder. Okay, so you're looking at a list of files. The precondition of this would be a list of files is displayed. Okay. The system response is to display the contents of the directory. Repeat step 1 until the desired file is displayed. So this is one of those cases where you say repeat. Okay, as I said, you want to minimize the number of these kinds of repeats, but sometimes it's inevitable. People do have to repeat something repeatedly, so here's the case. And then finally, when the until condition satisfied, select a file. Okay, and then from that point, we go back. The file's been selected, we've browsed for it. Whatever we were doing with that file, opening it, closing it, deleting it, etc., will then take place in the use case that includes this. Okay? Questions? Most people find the concept of writing use cases relatively straightforward. It's not a difficult concept to get. You just have to remember what they are and the basic rules we talked about earlier on of making sure that they're the true user interactions with the system, that they're not over-specifying the user interface, things like that. Sequence of steps, relatively straightforward. Okay? It's important work to help you work out the details of your system. Quite fast, doesn't take much time to write these things. You can go and play around with them with users and with user interface design experts until you get them right, etc. And you can use them as a basis for implementing the system. You can say, okay, first release of the system, we're going to implement use cases 1 through 25. Second release, we're going to implement another set of use cases. Okay? You can help them, you can use them to help you decide on what the architecture of the system is going to be. Okay? Here's a full set of use cases that we might end up developing in the 5th release. Okay, what kind of things do these use cases entail? They become a core part of requirements very often. Okay? Many requirements documents can be written to consist largely of use cases. Okay? So if you're going to be doing use case analysis, one of the techniques then is to create your use cases and then to decide which ones are the central or focus use cases. Okay? If you do that, then you sort of build the system around that use case or those use cases. It's like drawing class diagrams, identifying the central classes in a system. Okay? We're identifying the central use cases, the use cases that are going to be used most by users and are most important to users. And you say, okay, we're going to think about the process of building our first release by starting with that use case. And any other use cases that are inclusions of it, or maybe a few of the specializations, any generalizations of it, and other related use cases that are needed to help get its work done. And that becomes a release of the system. Okay? The functionality that's entailed in that small set, centered around the most important use case. So most systems have one important use case. If you're developing a bank account system, it might be withdrawing money from the bank. Depositing money is probably almost as important, but withdrawing is done more often. You deposit large chunks and you withdraw, smaller chunks of money on a more frequent basis. So that will be the thing that you have to focus on first. If it's a student information system, registering in a course is probably going to be the central use case. There's many others, but registering in a course would be the one that you sort of start thinking about. Another type of use case to pay attention to and to consider somewhat central, in addition to the one that is used the most, are ones that are high risk because they're going to be difficult to implement. So you can flag those and you can say, okay, we're going to put extra effort into these. We're going to put our top software engineers into these because they look as though they're going to be difficult. They require some special algorithms or some artificial intelligence or some other kind of pushing the computer science frontiers. And some other use cases might have high, what we call political or commercial value. They might be really cool. Okay? They might be displaying something graphically with all kinds of animation. Well, maybe that's not terribly important to the end user. But if you want to sell this and you're going to be doing demos, sometimes it's those cool things that can get you sales. Okay? Even though in the end they're not used very often. That's often the way it is. And so you might very well say, okay, we're going to put some priority into some of those things that are going to make they're not the bread and butter, but they distinguish our system in some way. Hopefully they're going to be used somewhat, but they distinguish our system perhaps from the competition. The competition and us can both do the core bread and butter ones. Here are some special ones. So for example, in a registration system, everybody can pick a course, register in the course. All registration systems do that. But our registration system, for example, has pretty pictures that show diagrammatically with all kinds of color coding different kinds of courses and their relationships, and it's animated and stuff like that. Okay, like the Green Navigator, the system that is available for students at the University of Ottawa. Okay, so that would be a selling point. It's not really an essential core part of the process, but it certainly gives you some kind of value added and some kind of perception that there's value here. So those are things to focus on when you're doing development of the system. Okay, so basing design on use cases, it can help define the scope of the system. Okay, so sometimes by laying out the use cases, you can say, okay, here's a set of use cases that forms the scope of the system. The rest of them are outside. Or the scope of release 1, the scope of release 2. Or the scope of subsystem 1, the scope of subsystem 2, developed by different groups. And that leads into planning. What are we going to do first? Who's going to do what use case? Okay, they can be used to develop requirements by playing around with sequences and to validate requirements. You can actually show these steps to users, because they're written in ordinary English and they're in the user's terminology. Not every end user is savvy enough to really want to take a look at use cases, but users of any kind of educational level above high school can probably quite readily read the steps. Do this, do this, do this. Does that seem reasonable to you? Okay, and if they have some kind of domain expertise, they might say, but, well, when do I do that step? Oh, we don't have a use case for that step. Or, what happens under this circumstance? There's no exception use case for that circumstance. We've got to put one in, right? So they can help you validate the requirements. They also form a basis for definition of test cases. How are we going to test the system? We're going to test the system by doing the use cases, by typing this data in, seeing what the response is, doing the next step, seeing what the response is. Now later on, we'll see that test cases add some additional information, and they actually act more like scenarios because we have to have actual data. But they form a basis for the definition of what we have to test in the system. And so it's very important. A lot of people these days are talking about test-first design. So working out use cases and then working out the test cases before you even get into this detailed design can help to you to develop a more reliable system. We'll talk about some of those issues at the very end of the course. And they can be used to structure user manuals. After all, what do user manuals often say? They often say, if you want to achieve this task, do this, and this, and this, and this, right? Now, you'll get a technical writer to make it very user-friendly, the writing in the user manual, or the writing on the online help. But the technical writer can take your use cases and make it into a user manual much more easily than starting from scratch. Okay? So a lot of reasons for doing use cases. Very powerful, very useful technique, even though it seems simple. A lot of things in software engineering are simple. A lot of people, say, gee, software engineering isn't nearly as hard as, chemical engineering. You don't have to learn all about thermodynamics and all that calculus. But an awful lot of people get an awful lot wrong in software engineering because they don't do the simple things. Okay? So really, doing use cases and saying, yeah, they're important, and let's follow a methodology where we're going to write them out. That's a core part of good software engineering practice. But use cases mustn't be seen as a panacea. There's been a tendency for people to say, okay, well, they're so simple, we're just going to write out a bunch of steps and then get on with the system. They've got to be validated. You can't just write out the steps. You've got to work with your users, okay? Not all aspects of the system are covered by use case analysis. In particular, the non-functional requirements are not covered by the use case analysis. The details of computations. Remember we said the functional requirements includes inputs, outputs, computations, data storage, timing. A lot of the timing is typically not covered, and the kinds of computations may not be covered. Okay, we're not talking about algorithms here. We're talking about computations from an end user's perspective. So you have to add extra stuff if you're basing requirements on use cases. You have to add extra details that are not in the use cases themselves. And sometimes use cases lead people to the obvious sequence with which users interact. And they don't lead people towards innovative user interaction modes that they might otherwise think of. Okay? So sometimes you don't start with use cases, you start with user interface design and you flesh out some screens and then you come back to use cases afterwards. And you go backwards and forwards. Because sometimes you can get a more innovative system by starting by drawing pictures or doing mock-ups and prototypes. Okay, so there's different strategies, but ultimately I think it's recommended to do at least the main use cases of every system. Okay? Any final questions on the use case topic? I know I've covered it quite fast, but as I said, it's a relatively straightforward thing. There were some exercises you can do in the book with some answers on the user manual, and I'll leave it to you to look into those kinds of issues. I want now to talk about the basics of user interface design. Again, we're going to go through this quite fast. The understanding in Chapter 7 is that this material is material that you should study in more depth. Use case design, you're going to study that in more depth in a course which will look at requirements and large system design and things like that. User interface design, typically most universities would have their own specific course, either called human-computer interaction or user interface design or something like that. And there is one in University of Ottawa, SEP 3120, okay? And there's also a graduate level course as well, which I'm teaching next term. So you can get into this area in a lot more depth. The objective of this material here is to make sure that everybody has a grounding in the basic terminology and the basic concepts, so that when you go out into your first work terms or summer jobs or whatever, you do have some core knowledge that you can apply, and you can be thinking about these things and observing user interfaces before you get a chance to take a user interface course. That's for the software engineers. The computer engineers, you might never really get heavily into software engineering, and you might not take this. This might be the only introduction you have. Okay? But everybody who's developing any software should have at least this much stuff. Okay, so first of all, user interface design is done in conjunction with other software engineering activities. There was a tendency historically for the user interface designers to be people, first of all, one class of user interface designer was the cognitive scientist, the psychologist, the human-computer interaction expert who had special training, didn't do any programming, didn't do any development, but basically just designed the UI. And that's very important and very good when you're designing new innovative modalities. So you're working at Apple, you're working at Microsoft, you're working at any of these companies that put out operating systems, or you're working at a company that does graphic design or large websites where you have a lot of freedom to develop complete innovation. Okay? It's good to have people who have that level of specificity and background. Okay? However, all software engineers will have to do user interface design at some point. Almost all. I mean, I would say 95 to 99% will. And probably a good 75% of computer engineers will, too. And so we can't rely on having these experts who are on their own, in their own field. So you have to do a lot of this work yourself. Okay? You also have to know when to defer to experts. Okay? So if you are getting into a totally innovative area, you really ought to have a consultant come in who's a specialist. That's one of the things that's true for all of engineering. Okay? You're an engineer, you have a specialty, okay, and you find yourself encroaching upon territory that you're not that familiar with, bring in a consultant in that area. Okay, so that goes here as well. So user interface design, whether it's done by one of these specialists or whether it's done by you, it's done in conjunction, or should be done in conjunction with the rest of software engineering. So in conjunction with the requirements analysis and the design of the system. And you're typically doing it in parallel. You're doing some prototypes in the requirements analysis phase that gives you some ideas about how the system is going to work from the requirements perspective. In the detailed design perspective, you're fleshing out some of the tidbits of that. And in the testing phase, you're testing the user interface. So all of this is done throughout the process. Use case analysis is an important step that feeds into user interface design. And as I said, you can do a bit of UI design, a bit of use case analysis, a bit of UI design, and back and forwards. Traditionally, in the field of UI design, the term task analysis has been used instead of use case analysis. But fundamentally, they represent the same idea. Another thing is you're going to do it iteratively. You have to develop user interfaces iteratively, because there's no way you're going to come up with a perfect one first off, with using just from first principles. You're going to come up with a picture, or you're going to come up with a prototype, you're going to work with users are going to tell you what's wrong with it, or you're going to discover what's wrong by observing users make mistakes, you're going to fix it, you're going to go back again, you're going to show users again, discover more problems, you're going to go back again. Okay? So that's one of the reasons why you don't develop the entire system. Because you might discover when you present with the use case or the user interface to users that they can't use it. And if the entire system is then built, then you've got to start the entire system again. So what you want to do is do user interface design on the basis of prototypes that you're going to throw away. You don't care about the prototype, so you're totally free to change it, throw it away, make a new one. Sometimes you even make 2 or 3 different prototypes with different ideas for a UI. You test them all out individually with different groups or the same group of users and pick the one that the users like the best. And then modify it, make it even better. Okay? Whereas with algorithm design, it's the technical person, it's the software engineer or the computer scientist that can figure out the algorithm and get it right. Not a hell of a lot of interaction with end users under those circumstances, except for what the output is. With user interface design, intense interaction with end users is always required. Okay, and you're going to have bad consequences if you try and think you can do it yourself. Okay, major system failures have been encountered by software engineers going off and interacting without user interaction at all, or not enough. Billions of dollars wasted, even in single projects. Okay, years ago there was the United States Federal Aviation Administration was developing an air traffic control system, and to replace a system that was built in the 60s. This was in the early to mid 90s. Okay, they spent 10 years building this system, and then they went to try to deploy it, and they found out lots of problems. Not all the problems were user interface problems, but one of the biggest classes of problems was that the air traffic controllers had trouble using the system. They just found that the user interface was bad. So that's 10 years of work and billions of dollars down the tubes. Okay? Okay, so if they'd interacted with the users on a regular basis, that would have perhaps saved a significant portion of that money. Because they would have discovered their problems before they built them deep into the design. Okay. Some terminology: usability, utility. Usability is how easy is it to use a system. Utility is what can the system do. So utility is the functions that the system provides. Usability is how easy it is to do those things. Okay? Again, the raw capabilities are the utility, and how the system is to learn and use is the usability. Okay? And the reason why I want to make sure you understand the difference between these concepts is that both are important. And it's important to think about both. It's important to think about the functions. They map to the use cases, they map to the computations, the functional requirements. But it's also important to think about the usability. And sometimes people focus on one and not the other. Okay, so you could have a system that is really cool and looks beautiful with all kinds of animation and graphics, and everybody says, wow, but it just doesn't really do the job. It doesn't have the functions you want. And then you have another system that is just sort of crunches away and hard to use and very basic, but it does do the computations. It might be very complex to use, difficult to use, experts required only, but it does the job. Okay? That's not terribly good either. It's good to have a program which will do the functions that everybody wants, okay, so they can achieve their goals, it can solve the problem, and it's usable so that it actually doesn't cause them, you know, all kinds of pain when they're trying to use it. Questions? Yeah?
Back to the example we just said about the traffic control software. You said the user interface is a separate part of the core software.
Okay, here.
When we design, we do not heavily based on the user interface so that it can plug into different interfaces.
Okay, his question is a very good one. He says, is the user interface a separate part of the system that can be developed independently so that you can effectively, develop the core of your system and then you can develop a user interface, and if the user interface is no good, you can throw it away and build a new one without having to throw away the rest of the system. And the answer is absolutely you should develop things that way. And if, for example, a lot of these expensive systems, I'm not sure whether the air traffic control system had that kind of architecture where the user interface layer was separate from the functional layer. That is considered software engineering best practice. I mentioned that to you very early in the course. Because then you can throw away a UI and you can plug in a new one when you want to, when anything changes or when you discover that you could do better. There are certain circumstances, however, when it's difficult to separate out completely some aspects of functional core from the user interface, particularly in systems that are very heavily based on graphics and display technology. Okay, so if, for example, I'm developing a user interface which is going to be displaying radars and pictures of flight paths and things like that, a lot of the function of the system involves actually around drawing these pictures. And so, in some sense, in those circumstances, yes, you do want to create pieces of code that don't have any UI, that do calculations of one kind or another. But in some sense, the UI becomes 70% of the system. Okay? Under those circumstances, when all the system is doing is complicated UI stuff. Right? Most systems, it's not like that. Most systems, you can put a very thin UI on top. Because basically what you're doing is the core bread and butter of most systems is, selecting from buttons, selecting from lists, displaying relatively simple data in forms, maybe some icons, maybe some tables. But all of that stuff can be abstracted away and can be just thought of as data. So you're putting data onto the user interface. The user is interacting with the data, issuing some commands to cause things to happen. And so you can do all the computation of that data, management of that data in one layer, and the display of that data, which can be displayed in many different ways, can be in the user interface layer, which can be replaced. But in an air traffic control system or in other systems, let's say a system for creating movies, okay, where the display is a huge part of the system, then that segregation becomes, well, you still do it, but it's just the user interface is that much more of the system. Okay? But that's a very good question. Very important observation. Any other questions? Okay. I'd like to break usability down into a number of aspects. Here are 4 of the more important ones. Learnability. When you're designing a system, you want to make sure that it's easy to learn. So that means the user should be able, ideally, to go in, look at the system, see the buttons and commands that are there, and know exactly what they all do, because they're obvious. So part of learnability is obviousness. The labels are there, or if they're not there, I can move the mouse over them, and immediately a little yellow thing pops up that says what they do. Okay? And if that is not possible, then the help is instantly available by just clicking on the thing, or it guides me through the process. Okay, so the ability to explore, the ability to figure things out for yourself, and even if I do have to refer to a manual, that there's no deep complexity, I can figure things out. Okay, So that's the first part. And you should strive for learnability as much as possible. Second part is efficiency of use. Okay? It's bad in a system if I'm always having to spend time moving the mouse around, backwards and forwards. Click on something, click OK. Move, click here, click, backwards and forwards, type something, open a dialog, open another dialog from that, close that dialog, move to another part of the screen, open a dialog, close a dialog. Okay? That kind of sequence is inefficient. It would be much better if I could just, on one screen, go click, 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 type, click, click. Okay, okay, done. Okay, you can see the difference between the modes. Maybe I'm achieving exactly the same task, but in a much more efficient way. The ability to do things completely with the keyboard is very important. Okay? For a number of reasons, but one of them being efficiency of use. The second one being some people are physically disabled find it difficult to use a mouse. Okay? Or a trackpad. So keyboard access is key for efficiency of use as well as other reasons. The other aspect of usability is error handling. Does the system help you when things go wrong? And things can go wrong all the time, as we said. Either you've done something wrong, so you have had difficulty, you're out of memory, or you've typed some wrong data, or you've installed something in the wrong place, or the data's not there, the person isn't, you don't have permission to do something. All kinds of things can go wrong. The system should help you out of your trouble. It shouldn't just say, cannot perform function. Okay, that is the epitome of bad UI design. Or even worse is error 68.93, you know? And there are systems that do that kind of nonsense. Okay? Absolutely useless and terribly bad design. Okay? The system should help you to recover from whatever the problem is as actively as it can. In fact, you might very well find that a considerable portion of your UI development work goes into helping the user out of problems. Okay, the simple, straightforward, obvious, here's the way it normally works, it might be easy to do. And then you spend 90% of your time dealing with helping the user out of problems. And then we have acceptability as the fourth major category. Okay, these are those leftover things which help the user to like the system. So it follows standards, it follows, it does things the way users are used to doing them so they don't have to learn something new. It has aesthetic appeal, it doesn't use bad color choices, it doesn't force you to squint at small fonts. Things that are partly aesthetic, but whatever it is, you don't want the user saying, I just don't like that system, it doesn't look good, it doesn't feel good, I find it awkward. Okay, now awkwardness could be learnability and efficiency of use, but it might just be the user's perception. So users' perceptions are important here, and doing studies of whether users like it or not, and what they don't like, even if it's not really learnability or efficiency of use or error handling, can turn out other things you need to change. So categorizing these four types of usability can help you to focus on the different aspects and make sure you try and address all of them. Questions? You'll notice that these apply in other areas of engineering too, right? Okay, so if I'm using some kind of mechanical device, I should be able to learn it, how to use it fast. It should be efficient to use. If the things go wrong, I should be able to easily recover what's gone wrong in the mechanical device. And it should be aesthetically nice, so it's got a good industrial design. The car looks nice. It doesn't look like a box, right? Same concept. Learning is a key part of it. I put that first for a reason, because it's probably the more important of those. Error handling is probably close behind, but learning is very important, and often learning entails error handling anyway. I think it's important that everybody have an understanding of learning curves, okay? People learn, first of all, they know nothing. So if you look at the bottom left-hand side here, people know nothing, and then they learn. And so the x-axis here is the y-axis is the percent of the system known. So this is how much people know, up to 100%. And the x-axis is the days of time, the amount of time it takes. Now, if it's a simple system, you know, this could be day 1, day 2, day 3. Here I'm showing 31 days, you know, to get to 80% learning of some system, okay? And this might be just the first release, okay? So 100% of the functions in the first release. Okay, so, and typically these learning curves look like S-curves, as they're called. They start off, they curve up, and then they level, they come to a steady increase, and then they start to tail, the increase starts to decrease, and then gradually, asymptotically approaches some fixed upper bound, okay? And so what I'm showing here is 3 different learning curves. Okay, the first learning curve, simple system, easy to learn. That's the one with the bold, solid line. Okay, so it's a simple system, so it has less functionality. So the total functionality ever in this system is the 50% of the other system. Because they're never going to get to this 100% level because the system doesn't have all that stuff in it. That's why it tails off at the 50% level. But because it's simpler, the learning curve will more rapidly get up to a higher level faster. Okay, so it rapidly rises and then tails off at that close to that 50% level. Simple system that's hard to learn will approach the same 50% level. Maybe never quite get to the level of usability or the amount learned that the easy system did, but it will approach it. But it will be more delayed. Okay, so we can see that there's some kind of delay. It takes twice as long. It takes to get to the 20% level. The easy system, it takes 3 days. It takes about 6 days, 6.5 days for the more complex system. And so that's the difference. You have a more complex system, harder to learn system, takes longer for users to learn. Straightforward enough. It's useful to kind of plot your learnability curves or your learning curves by actually observing users learn so that you can get an impression of how much time it actually takes people to become productive. Some systems will take many months to approach full productivity, complicated systems. Yeah? Because I've defined the simple system as only having 50% of the functionality. That's what I mean. I've defined the simple system as having 50% of the functionality of the complex system. Up here, I'm showing that typically users would only ever learn 80% of the system which has all the functionality. So this simple system only has half the functionality. Okay? So they still get to 80%, but it's 80% of less. So 80% of 50% is sort of 40%. So that's where we're tailing off at here. All right? You might have heard of steep learning curve. That term is used incorrectly. Steep learning curve is actually good. This learning curve here is the steepest one. It means they're learning faster. So when people talk about a steep learning curve on the system, what that means is they're learning fast. It doesn't mean it shouldn't mean they're having a hard time learning. But historically, people in the popular press have adopted this steep learning curve to mean not learning fast, but having difficulty learning. And that's not what it's supposed to mean. Okay? Okay, the difficulty learning, in fact, is a shallower learning curve, like this one here. Okay, so just an interesting observation in how the colloquial English has adopted what they thought was a perfectly well-defined concept, but they've got it wrong, in effect. I'm going to give you some guidelines about user interface design in a few minutes, but we have to learn some core terminology first. A dialog, okay, spelt with an extra UE, and if you're in Europe, this is a window, typically, which the user can interact with, okay, but which is not the main UI window. So a dialog is something that pops up, which you type stuff in, and then you dismiss the dialog, close the dialog, and you go back to the main window. Okay, I'm sure you've probably all heard of that. There's other uses of the word dialog as well, but this is the one that we're typically going to be talking about when we're doing UI design. A control, also known as a widget, the widget was the original terminology, control was a Microsoftism that is now being adopted more widely, is some component of the user interface that you use in the design process. So a dialog is a kind of control. but so is a pop-up menu, so is a button, a radio button, a scrollable list, a piece of text, an image. Practically anything is considered a control. Okay? Or widget. I like the term widget, but control is the term that people tend to use these days. Affordance is the set of things the user can do in a given situation. So what are the things the user is capable of doing? Maybe all the user can do is click one button, the OK button. Maybe that's all they can do in some highly restrictive circumstance. The system says, your data has been saved to the database. OK. That's all you have is the option to click OK. That's the affordance. That's the only piece of it. On the other hand, if you open up Microsoft Word in a document, you have hundreds and hundreds of pieces of affordance. All kinds of menus you can pick, all kinds of buttons you can click. You can type the text. You can click all kinds of control sequences that do all kinds of fancy things. Lots and lots of things you can do. The state is a stage in the sequence as we're moving through the system in which certain things can be done. Okay, so as we move through a use case, we move from state to state to state. Okay, maybe the first state is I've got a list of courses. Second state is I'm displaying information about a particular course. The third state is I'm displaying a confirmation dialog. Okay? And in each of those states, I can do different things, and different things are true. And so I study the user, what is the affordance of each state, what are the controls that present the information in each state, and so on. State and mode are closely related to each other. Okay? A mode is a state in which the system is very restrictive. And we talk about a modal dialogue as being a dialogue in which all I can do is interact with that dialog box. I can type something into it maybe, I can click cancel, I can click OK. Okay, so modal dialogue is a very restricted state. What we want to try and achieve is minimize the number of modes. We would like to be able, for example, instead of having a modal dialog popping up, where all I can do is type OK, cancel, that I have a non-modal dialog pop up, and I can leave it sitting there on the side of the screen and continue working. And I can click OK and cancel whenever I feel like. That's non-modal, because it isn't restricting me from continuing to work. I don't have to respond to this nonsense thing. Okay? Every now and then in some Microsoft programs, you get these things popping up where it says, it appears that you are trying to write a letter. Do you want to do this, that, and the other? And it's modal if you have to say no. It's non-modal if you can ignore it. Okay? Basically. And so non-modal tends to be less annoying and tends to be more productive. You can get on with your work. It's probably still better if some of these things don't pop up to start with. That's another issue. Feedback is the response the system gives you that tells you what state the system is in. Okay, so if there's an error situation, then feedback will tell you what that error is and what you can do about it. At least that's what the feedback should do. It doesn't always do that. Okay? Or if you have saved successfully, the feedback should let you know that the system has saved successfully. Okay? Or if you're allowed to do something and not allowed to do other things, the system will tell you what you're allowed to do, what you're not allowed to do. You shouldn't sort of try typing something and then the system says, sorry, you're not allowed to do that. After you've gone to a whole bunch of work. Feedback should give you information as soon as you enter a state about what you're allowed to do in that state. Encoding techniques are ways of representing information to the end user. So I can use sound, I can use beeps or music or whatever. I can use visual cues, color coding, particular icons, boxes around things, pieces of video. Okay, those are visual kinds of encoding techniques. Under some circumstances, I can even use coding techniques that apply to other senses, like vibration. My cell phone's ringing. I feel a vibration. It's tactile. Okay, it's another encoding technique. So part of the process of designing UIs then is to decide on what dialogues widgets are going to be there, what the affordance of each is going to be, what state the system goes through, typically corresponding to steps through a use case, minimizing modes, providing good feedback, and choosing the appropriate coding techniques, choosing the fonts, choosing the colors, choosing the sounds, where they're going to be located, all kinds of issues to do with that. Okay? Some principles. Okay? First of all, I'm going to give you a set of principles, and I'm going to say these principles are only principles. Sometimes you violate them. So principles are not hard and fast. You always have to test with users anyway. You can use these principles to give you a good first prototype, but the user still might find problems. Second principle, base the UI design on the use cases, on the user's tasks. Okay? So you figure out from the use case design what the sequences are. You then design a user interface to provide those sequences. Or maybe the other way around, but you're still going to develop use cases and then go back to the UI in the second iteration. Third principle, simplicity. Okay? There's an old adage in engineering, keep it simple, stupid, the KISS principle. Okay? Simple designs are often far superior to complex designs. Simple web pages are often much more pleasant and easy to use and considered better than web pages that jam so much stuff into their home page that looks so busy. Okay, so try and keep it simple. Reduce the amount of reading people have to do so they can read quickly and do the job they want. Reduce the amount of manipulation they have to do. Fewer pop-ups. They can just click things right on the screen. Tends to be better. Okay, but as always, there are exceptions, so test with users. Okay. I've come up with very simple designs before when the users have come back and said they'd like to have more sophistication. But better to start off with simple, and then have the user prompt you for sophistication, than to start off with sophisticated. That would be what I would suggest. Try to avoid the user needing to navigate somewhere. Navigating is saying, I'm in one place. To do something, I have to go through a sequence of clicks, or sequence of menus, or sequence of dialogues to get somewhere to do something else. Okay? So if the user is going to frequently have to go from A to B, one click should take him there, or her there. Okay? By the way, all of these principles and all of these UI design things apply to all kinds of applications. So whether the application is on Microsoft Windows or Macintosh regular application, or whether it be on a cell phone or a PDA, small device, okay, or whether it be over a telephone, okay. You know, you dial a system and you get into voicemail hell, you know. Well, a lot of these user interface principles apply there too. Keep the menus simple, stupid, you know. Right? You don't like to go through long menus that it says, you know, if this, press 1, if that, press 2, and 5 minutes later, if that, press 9, you know. Oh, if I'd known, I would have. So all of these are user interfaces. They've just got different kinds of screens. And web pages, of course, they're just user interfaces too. Okay? Ensure that the user always knows what he or she can do and should do next. So the next logical sequence in a use case should be blindingly obvious to the user. And also it should be obvious to the user the options they have. It shouldn't be hidden things. The user shouldn't have to go look in the manual for what they can do. It should be available on the menus. They should be able to look at the menus and see the options. Or see them listed as icons on the interface. And the most important ones should be the most obvious. The top of the menus. Or as buttons right on the screen. Provide good feedback. I mentioned the concept of feedback. So feedback involves informing users of the progress and the location. So wherever you are as you're navigating, the user should have an idea. They should have a mental map of where they are, and this map should be visible to them somehow on the screen. A lot of web pages will tell you home page, second page, third page you navigated to, and I can always click to go back to the home page or to back to the previous page, and so I see a little sequence that sort of looks like this: the home, and then I went from there to, you know, to corporate, and I went from there to, you know, to share price. Okay, this is where I am now, so that's highlighted. But I can see that I can quickly navigate back to here or navigate back to there. So I know where I am. And if I go from here into something else that is sort of detailed about his history of the shares of this company, then I can see where I am as well. And so I'm getting feedback on the screen at all times as to where I am and how to get back. That's a typical piece of design that's good for web pages. It's also good for other systems that navigate, not just web systems. And when something goes wrong, help the user resolve the problem. So if the problem is permissions, okay, you don't have authority to do that. You don't just say, you don't have authority to do that. You say, well, it could be dial the following phone number to communicate with a particular person who can give you authority. Or fill in information here and we will communicate with the person to get you the authority. You know, or type the following password in. You know, or if it's a particular file that is read-only, let's say, the system could say, you know, you don't have authority, the following file is read-only. And then you have a button that allows you to navigate to that file in your browser so that you can maybe change it if you have the right to change it, okay? So rather than just saying you can't do this, don't have authority, or read-only file system or something, it tells you what is read-only and gives you some assistance to quickly fix it. Those are better systems in general. Any questions at this point? Okay. Ensure the user can always get out, go back, and undo. Alright? So, if the user can always get out of something, they're not scared to go in it. If they can always go back, they're not scared to go in it. And if they can always undo. If I can always type something and then I realize I made a mistake and I can click undo in the menu, which is usually in a standard place in the edit menu, then that means the users will be able to work faster because they won't have to think quite as much because they're not quite as paranoid about making mistakes. Okay, and undo, which goes back a whole bunch of steps, so I can undo 5 or 6, 10 steps is also even better than a one-step undo. So if I realized 15 minutes ago I made a big mistake, I can just undo back to that point. And so you should build in undo into as many systems as you can. It's not always possible, like format this disk. Well, you know, if you're giving an option to format the disk, then you don't just format the disk and then have sorry can't undo. The approach there is, do you really want to format this disk? Do you realize that the information will be permanently irretrievable? Okay, format the disk. Okay? It doesn't just say okay, it says okay, format the disk. It's much better, you know, to make sure that they're really, really confident about it. Okay? And then maybe even in something drastic as that, it waits 5 seconds, preparing to format the disk with a cancel. You know? So that if I accidentally hit OK, I can still cancel for a few seconds, you know, for drastic operations. You know? But many things are not as drastic as that. So I've added a new person into the database. Undo. Takes that person out of the database. Okay? Provide such facilities. It makes the system much more usable. Principle 7, response time. These days, response time should be a no-brainer. We have computers that are so incredibly fast compared to what they were 10 years ago or 20 years ago. Unfortunately, people tend to do design that's inefficient or add all fancier and fancier graphics to their systems to eat up any speed they have in their computers, so you can still have bad response time. Or the network is the delay, again, often because of trying to download way too much stuff. Okay? I think you should put fast response time above and beyond any considerations of nice fancy stuff, fancy graphics, fancy whatever, okay? Response time is where people get productivity out of. Okay, if we could speed up the response time of of many applications, we could save vast amounts of money and make people much more happy with our system. So put priority there as a rule. Many systems are way too unresponsive, especially web systems. Don't rely on expecting people to have fast computers. In corporate environments, computers are replaced typically on a 3-year cycle, sometimes 2 years, but often 3 years. Okay, so expect that people will be using 3-year-old computers. That's the norm. And sometimes even 4- and 5-year-old computers. That is quite common in organizations still. Organizations like to save a lot of money. Okay? So keep response time less than a second for most operations, instantaneous for frequent operations and editing and things like that, and warn users of longer delays, inform them of progress. Okay, I just can't emphasize how important I think response time is in general. Use understandable coding techniques. So understandable means colors that have meaning to people, text, words that have meaning to people. We're not using jargon they don't understand. Sounds that make sense and aren't just there for the sake of having sounds. And uncluttered UI. We don't want UIs that are just full of mess and junk. Okay? We want UIs that are easy to quickly glance at and people can see what does what. Consider the needs of different groups. Okay? So the disabled is a key group. Blind people should be able to use systems with aids that will read text for them, and therefore you mustn't just encode information in images. That's one of the classic rules of UI design. Okay, we also have to take care of deaf people, people who have physical disabilities as well. Okay, and there are different strategies for that. And take care of beginners and experts. Okay, so experts sometimes need an advanced mode that allows them to do more stuff. But beginners, that would be confusing. So you provide a button that toggles you between beginner and expert if your system is at a certain level of sophistication. And provide online help. Okay? Online help is important. It needs to be easy to navigate, answer the right questions. It needs to be tested so that users will go in, try out questions, and actually return responses that are appropriate. Often online help isn't tested properly. It needs to be accurate as well. You often find online help is a bit inaccurate because it's earlier releases and stuff. Okay? And the final usability principle is be consistent. So throughout your application, if you're using one style, one font, one color scheme, one set of icons, be consistent through the application. Or be consistent with the rest of the operating system or other applications that are being used at the same time. There are standards published by companies like Microsoft and Apple and others for user interface. So follow those look and feel standards so you're consistent with them. And consider mimicking other applications. You don't want to copy somebody's patented scheme, but you do want, if there's ideas that are being widely used, to mimic those ideas because end users will be familiar with those ideas. Okay, now we're going to end it in a couple of seconds. We're a little bit behind schedule. We're about one lecture behind, okay? But we should be able to catch up as the rest of the course goes on. So we'll finish off Chapter 7 quite quickly next day and then move right on into Chapter 8, okay?